Hello everyone. In this presentation, we are going to analyze and visualize the garment industry data set, and we are going to evaluate the machine learning models built to predict the productivity of the employees. So as we know that garment industry is a highly labor intensive industry where a lot of manual process goes on, and there is a huge global demand for this industry, and decision makers in the garment industries are trying to track and analyze the data to predict the productivity of the employees to improve on the same. So this is little bit about the data set, and this data set includes the important attributes of the garment manufacturing process and the productivity of the employees. So this has been collected manually and validated by the industry experts. The data has been collected through a period from January 2015 to March 2015, and this data set can be used for both regression and the classification purpose. While doing the regression, we can predict the productivity which ranges from 0 to 1, and while doing the classification, we can classify this productivity range, and we can build the classification models to predict whether the productivity has been achieved or not. Before building the machine learning model, we are going to do some exploration of the data and visualize the data here. So here is the first one. So here we are going to see how is the actual and target productivity is distributed in the sample. This blue line shows the actual target productivity, and this red curve is the actual productivity. We are seeing that the target productivity most of the time is set to 0.8, and the actual productivity, the employees were able to achieve this target, and they were even able to go beyond it. This data is slightly left skewed, and when we see the target variable, this target achieved, when we check the frequency in the sample data, we are seeing that most of the time the target has been achieved. Around 80% of the data says that the target has been achieved. So this could be an imbalanced data set. How is the sample data distributed across the quarter column? So every month is divided into quarters. So in a month, there are 4 quarters for every week. And if the month has 5 weeks, then we get this quarter 5 also. So that is why we are seeing that there is a minimal data for quarter 5, and all the other quarters are almost distributed. So how does the quarter column relate to the productivity of the workers? When we see that quarter 5, we are seeing that 84.1% of data says that the target has been achieved, but this could be little misleading, as we saw in the previous slide, that the quarter column has a very minimal data. So when we check quarter 1 to quarter 4, we are seeing that quarter 1, 74.7% of the data says that the target has been achieved. So next we will see how the productivity of the workers vary through the month of Jan 2015 to March 2015. So this blue curve is the target productivity, and this red curve signifies the actual productivity. We are seeing that until the mid of January, the target productivity and the actual productivity are going hand in hand, and there is a peak during the month of February, and there is a dip in the beginning of March. How is sample data distributed with respect to departments? So we are seeing that there are 2 departments in this data, sewing and finishing. So sewing is comparatively having more records as compared to the finishing. So which of the 2 departments have achieved the target most number of times? So we are seeing that sewing has data which says that 82.1% of data says that the target has been achieved for the sewing department, and for finishing only 60% of the data says that the target has been achieved. Did idle hours or idle men affect the productivity? Yeah, there are some idle hours and idle men in this data set. When we plot, when we build a pie chart around that, we are seeing that 22.2% of the data says their target is achieved when when there are idle hours and idle men, and the productivity is good. The target is achieved 73.4% of times when there are no idle hours or idle men. How is the productivity of each team? So we are seeing that there are 12 teams in this data set, and team 1 has done a really good job when their set target and they have achieved more than what is targeted. And even team 12 has a high target, but they managed to achieve this. And when we see the team 6 to 11, they were not able to achieve the set target for them. Did incentives help in increasing the productivity? When we see this pie chart with the incentive, we are seeing that 90.2% of the records with incentive says that they have achieved the target. Without incentive, only 56% of the data is saying that they have achieved the target. But when we plot a graph between incentive and actual productivity, we are seeing that with less incentive also the target has been achieved, and with more incentive, less target is there is a very less actual productivity. So this data is bit inconclusive because of this graph here. Are there any correlation between the features? Yeah, so we are seeing that there is a high correlation among the number of workers and SMV column, and there are some correlation between the SMV, WIP and overtime columns here, and there is no very specific correlation among the individual independent variables and the target variable. So we are going to evaluate some models which were built on both regression and classification algorithms. So first we will see some regression models. So linear regression model, there were 4 models built on linear regression algorithm, and when we see the adjusted R-square value for the train and test data set, we didn't get any best result by doing either by removing the independent variables or by adding only variables which are correlated with the actual with the actual productivity and by doing cross validation. So this is the maximum which we could achieve with the linear regression models. When we see the decision tree regressor model, there are 3 models which were built with this decision tree regression algorithm. The first model is just a preliminary decision tree, and this data where the adjusted R-square value is for training data set is too good, and adjusted R-square value for the test data set is so poor. It appears like this model has literally mucked up the data and was not able to perform in the test. And so the best which we could achieve with this is 0.48 and 0.31, which is not an ideal model. So random forest regressor model, when we see, so 3 models were built on it. The first model also behaved like the data has been overfitting has happened here. And this is the best model which we could build with the regression algorithms. So 0.74 is the adjusted R-square on the training, and 0.68 is the adjusted R-square value on the test. So we will see some classification models which have been built. So this is the logistic regression algorithm. So there were 2 models built for based on the logistic regression algorithm, and we see that the model 1 is showing the good accuracy and F1 score. We are going to concentrate on the F1 score because we have already seen that this is an imbalanced data set. So 0.86 is a good score when we come to the classification algorithms. So there are 2 models built on the decision tree classifier algorithm. So this first is a preliminary decision tree, which has also given a good accuracy and F1 score. But again, on tuning with the cost complexity pruning, we are able to achieve an accuracy of 0.83 and 0.89. So we can see that what if we can do better with the random forest classifier model. So yeah, 3 models have been built around it. First is the preliminary, which has also given a good result, and second is using some specific parameters. We have got this result, and using the random search CV and grid search CV, we were able to achieve an accuracy of 0.87 and F1 of 0.91, which is the best model so far. And in summary, we would say that in the regression model, we got a best model with the random forest regressor with adjusted R square for the test data is 0.68, which might not be the very best prediction model, but this is the what I have got from this. And this is the classification model where the random forest classifier with random search CV and grid search CV are able to achieve 0.87 accuracy and 0.91 F1. So this is all we have here. Thank you so much.